going to start out not by giving you a quiz, as some of the other folks have, but just asking you a few questions to get you thinking about whether you've been noticing cover crops. Have you noticed radishes or turnips or other things that are normally considered to be forages in fields where you know the producer doesn't graze animals, or maybe that producer doesn't raise animals at all? Have you noticed aerial applicator planes flying low even after the chemical application season is over? Have you noticed coffee shop talk? I know that you all take a coffee break and you go to the local coffee shop, and have you noticed talk about record radishes rather than record corn yields? I have. Have you noticed, or have some of your colleagues noticed, producers calling and asking about cover crops and what should I plant and when should I plant it and what am I going to get out of it anyway? Have you noticed lots of field days about cover crops? Well, I'd like to suggest that there's a cover crop movement sweeping across the Midwest, and you're all invited to join in. This has been particularly the case, actually, in the eastern part of the Corn Belt, Ohio, Indiana, and Michigan the last few years, but there's interest throughout the Corn Belt. And that interest is sparked by a number of different factors, and you all could add some other factors to this, I'm sure, but just to quickly name a few, and actually, as John intimated, a lot of this is being driven by farmers, and we researchers and extension folks are working along with farmers on these topics. But some of the reasons I think that there's increased interest the last 3 years or so is higher fertilizer and energy prices always cause people to think about how they can be more efficient with the inputs that they do purchase for their farms. And cover crops might be one way to assist with that. Certainly concerns about water quality, the desire to improve soil quality and biology, desire to improve nutrient cycling, reduce losses of nutrients, and certainly concerns about erosion, particularly, and soil organic matter, particularly if we end up in situations where we are removing large amounts of corn stover for bioenergy. So these are some of the reasons that I think the interest in cover crops has really grown the last 2, 3, 4 years. Let me start out by just making sure that everybody understands what we're talking about with cover crops. So what are cover crops? Literally, they are crops grown to cover the soil between cash crops. So the focus of our studies here for the CAP project are particularly on winter cover crops. So basically, we're trying to cover the soil in the winter between our corn and soybean crops. So sometime after we harvest corn or soybeans in the fall, have the soil covered up until the point where we plant our corn or soybeans the following spring. There are many different species of plants that can be used and are used as cover crops, each of which have advantages and challenges. So there is no one magical cover crop that will be able to apply all across the Midwest for every purpose. I'm going to show you some pictures of just a few of the cover crops that are being used in the Midwest. Annual ryegrass is one of those that's been fairly popular the last 3, 4 years in Ohio and Indiana. And basically, it's a, you could see perhaps some of the fibrous roots that are breaking up some of the shallow compacted layers that we might have in some of our fields. So annual ryegrass is one. This photo here is from Iowa, from Tom Casper at the Tilth Lab. Oats after soybeans in the fall. The oats will winter kill, but he had a very good production of oats in that fall. Another picture from Indiana. This is a mixture. Farmers are interested in mixtures. This one of radish and annual ryegrass. In this case, the farmer grew wheat and then applied manure, and these cover crops were planted in August, so a huge amount of production. And we went out and looked at this the day after Thanksgiving a couple of years ago. So the cover crops can range from large amounts of production to somewhat less production. This is another field in Indiana, an oats and radish combination seeded into standing soybeans, much less growth, but still appreciable growth and good benefits to the soil. How do you sample cover crops? A picture's worth 1,000 words, right? So putting a frame down and using little grass clippers, hand grass clippers, putting the sample into a paper bag and drying it and weighing it gives you your cover crop biomass, and then you send that away for analysis to get your nitrogen analysis, and that's one of the simplest ways to get cover crop data from plots or farmer fields. Another picture from Iowa really graphically illustrates, I think, that one of the benefits of cover crops. On the right is corn silage ground the following spring with no cover, bare, erosion. You can just see the loss of organic matter, the crusting, and the poor soil quality. On the left is cereal rye, which is the standard cover crop that we're using as part of the CAP project because it's the most versatile to fit across the whole region. Protecting the soil, putting carbon back into the soil, cycling nutrients and trapping nutrients. Okay, what I want to do is talk about very, very briefly what are the potential benefits of cover crops, which essentially leads into how they would contribute to increased resiliency of our corn production systems. Again, not any one cover crop will do all of these things, okay, but they will, and so you choose your cover crop based on what you're most interested in. Some of our cover crops are planted as nitrogen scavengers. They basically trap nitrogen that would otherwise be lost during the non-growing season. Maybe instead we want a cover crop that produces nitrogen, so a legume that's going to put nitrogen back into the soil that our corn crop can use the following year. The traditional reason to use a cover crop is to reduce soil erosion, but even on flat soils that are not subject to erosion, cover crops have many benefits. Improved soil quality, increasing soil organic matter, sequestering carbon, conserving soil moisture by having a mulch on the soil surface and reducing evaporation, recycling nutrients, and many of these, both directly or indirectly, will contribute to increased crop yields and increased crop yields over the long term. I want to stress over the long term. We can't expect benefits from these cover crops generally in the first year on overall crop yield, but they will be contributing to decreasing year-to-year variability in crop yield, which is a part of our resiliency question. So in your packet somewhere, there are the list of all the research questions that we came up with as a project. The cover crops fit into two of those. Research question 13, how do winter cover crops affect the resiliency of corn production through alterations in carbon and nitrogen and water footprints in the soil? And how do winter cover crops impact the greenhouse gas footprint of corn production systems? So those are the questions that we are focusing on. I want to give you a little bit of the concept of the cover crops and why we think cover crops would have an impact. The basic concept is very simple. We are talking about having a living, growing plant at times of the year when we normally don't in a corn-soybean system. It's really that simple. And so if you have a living and growing plant, it's going to be capturing sunlight, feeding soil organisms, sequestering carbon, trapping and recycling nutrients. I'm going to illustrate this in the next two slides with some diagrams or photos. So this photo is, or this diagram is kind of my cycle of the year that we have in our Midwestern systems. And of course, our corn-soybean system is normally fallow from October through April. Okay, we harvest in September, October, and we have nothing growing until the following April or May. Unfortunately, however, for nutrient loss, the majority of our drainage flow and the majority of our nitrogen losses out the bottom of the root zone occur precisely during that fallow period. We have excess precipitation, we don't have a crop growing, taking up water, we recharge soil moisture, and then the rest of it goes out the bottom. And whether you have a tile drain or whether you are just going towards groundwater or lateral flow to streams, the majority of what we lose out of the crop root zone is lost during the fallow period. So the basic concept then is that by planting a winter cover crop, we're going to have something growing and taking up nutrients during the fall, maybe even into December in many years. It'll go dormant in the winter, and then if you have a cover crop that does not winter kill, it will grow again in the spring. But basically, you're taking up nutrients during a time period where we normally have nothing there to trap the nutrients. So really a very simple concept, but very effective. Another way of looking at it, my colleague Tom Casper at the Tilth Lab in Iowa likes to talk about this 7-month brown gap that we have with corn-soybean systems in the Midwest. This was a couple years ago at the Purdue Agronomy Farm. We had an early harvest, September 1st, soybean plots on the left, corn on the right, harvested September 1st, brown. Going to be brown until next May. In the middle of those plots was a grass strip. It wasn't a cover crop, but it's simply illustrating that the normal grass we have growing everywhere is green and growing through November, sometimes even into early December in much of the Midwest. taking up nutrients, fixing sunlight, putting carbon back in the soil, trapping nutrients that would otherwise be lost. We have substantial growing season left after our corn or soybeans in the Midwest that we could be using for better use. So how do these cover crops affect resiliency? Basically, we're improving soil quality, which is going to increase crop yield over the long term and reduce year-to-year variability. We're reducing nitrate leaching, and we are conserving soil water, which will reduce year-to-year variability, and in dry years, we would hypothesize is going to increase crop yield. I'm going to finish up with just a couple of slides on how do we take this information and how do we actually fit it into a farm system. As John was talking about, there are reasons that farmers do not use cover crops. There are practical challenges. And so we have some work that's going on. Several people that are in the CAP project are also involved with the Midwest Cover Crops Council. We developed a selector tool that's been online for about 1.5 years now, and it covers all of the Midwest, and it's basically trying to help farmers and advisors select cover crops that would fit in their system and in their geography, has the frost dates and everything for each of those areas. We have a pocket guide on cover crops. Again, this was a regional effort of advisors and extension and researchers from throughout the Midwest. Just came out at the end of February in this year. And my final slide would be to just present what some of those challenges are. Cover crops in a corn-soybean system are more challenging than in some of our other systems like after wheat or after corn silage. The timing is difficult. If you can't plant the cover crop until after harvest of your main crop, it limits your choices and it limits the growth potential. The seeding and establishment, there are other ways of seeding, and farmers are doing that other than just waiting until after harvest, but there are challenges there. Certainly people are dealing with those, but there's a lot of work that's needed to make those even more practical. Timely termination or killing of the cover crop in the spring is sometimes a challenge, and the lack of short-term economic benefits is often a challenge to farmers, particularly on land that they do not own. But there's the potential for a lot of excellent benefits, and that's certainly why a number of folks are evaluating cover crops. So, thank you.